Hey everyone, welcome back to my daily coding series. Today is day 60. So I'm just going to keep going with this neat code roadmap here, and today we're going to look at a 2D dynamic programming question. So I guess I kind of know longest common subsequence, the approach to it already, so I'm just going to go to this one, which I've never seen this before. Okay. So it's called best time to buy and sell stock with cooldown. Okay, so we're given prices, and every index is the price of a coin on the ith day. We can buy it and sell. Okay, we can buy and sell one neat coin multiple times with the following restrictions. After you sell your neat coin, you cannot buy another one on the next day, and we can only have one. You may complete as many transactions as you like and do the maximum profit. Okay, so we're trying to get the maximum profit. I think the tricky part is the cooldown. So, okay, so I get what this question's asking. So let's look at the test case here. Oh gosh, that's blinding. Let me fix that. All right. So 1, 3, 4, 0, 4. This is our test case here. So buy on day 0. So we're at -1. Right? Is that how that works? Okay. And sell on day 1. So then we get 3. So then our total net worth is 2. We can't buy on day 2 because of the cooldown. So we're going to buy on day 3 for 0. So -0. So we're still at 2. And sell on day 5. And we will get another 4, and we'll end up with $6. Okay. All right, so obviously this is under the 2D dynamic programming section. So nothing's really coming to mind right away. I don't even know how you would brute force this, so let me try to think about that. So I guess we'd want to find like the biggest like the biggest gaps. Maybe we can represent it like this, and then okay, so if we represent it like this, and let's say this means, so let's red will be buy and green will be sell. So if we buy, so at the very first day we have a choice to buy or not to buy. So I don't really know what this array means, but let's just say we buy. Then we could either sell. All right, so I'm going to look at this as a decision tree actually. So if we have 1, 3, 4, 0, 4, and then we can either buy or sell. Okay, so on day 0, we can either buy or not buy. So if we buy, we'll be at -1. And if we don't, we'll be at 0 still. Okay, and now we can either, so now we can buy, do nothing, or sell. So I guess this is how you would brute force it, is you would do all 3 of those, because at every step you have a decision to buy, not buy, or sell. So then here we could, so let's say it's buy. Okay, yeah, so let's say from left to right, it's buy, don't do anything, and then sell. So if we don't do anything, we're at 0, and we can't sell because we have no coin. So then the problem narrows to this. So then if we look at the 3 choices from each of these, so to buy here, we can't do because we already have a coin. To do nothing, we would stay at -1. And then to sell, we would go to 2. All right, and then at this other case, where we do nothing, so this is I equals 0, I equals 1, so every height is a different I position. Okay, so at this point, we can't sell because we don't have anything. To buy would put us at -3. To sell, or sorry, to do nothing would keep us at 0. So yeah, this is how you'd brute force it, and then you would just keep in mind that right after you sell, you can't buy. So like this node we just sold. So if we had 3 nodes, we couldn't. Our only move, so we can't buy because of the cooldown, and we can't sell because we have no coin. So our only move is to do nothing. That's the cooldown there. Okay, so I don't think that would be an efficient way to do it because it would be like 3 power n. So what can we do? So we have those choices. We can buy or sell as many times as we want. So that makes me think of subproblems. So for instance, like if we have this subproblem, we have to think what's the maximum that we can get in this period plus the maximum we can get in this period. But this cooldown is the hard part. So you could say, like, if it's only here, then that allows us to have this period instead. So the cooldown part moves, if you see what I mean with this example. So yeah, that's the repeating subproblem that I see, is basically in one portion, how much money can you make? And what would the base case be? Where can we start? So if we have, I'm going to undo that. Okay, so we know that with an array of size 1, like let's say it's just 6, what is the, yeah, so it could be size 1. So what should this return? In this case, the maximum profit we can make is 0. So we either can buy the coin and lose 6 or sell the coin. Okay, so now, so what if we add another number? So if it was like 6, 2, then our answer is still 0 because we go from left to right, right? Yeah. If it's 2, 6, then the answer is 4. So in other words, the profit, so if we have a size, if we have 2 days, if our subproblem is 2 days with a value A on the first day and B on the second, our maximum profit is B minus A if B is greater than A. Otherwise, it's 0. So this is our base case if there's 2 elements. If there's 3 elements, so let's say we have, I don't know, 6, 2, and 5. So in this case, we would subtract, well, in this case, we would buy for 2. Wait, did I get this right? If B, no, I think it's actually the other way around. If A is bigger than B, because we have to buy the bigger one. And no, that's not right. We have to, well, okay, if I have like 2, 6, we buy the smaller one and sell on the bigger one. So we want B to be bigger than A. So I think I actually did have it correct. Okay, so here, what are the subproblems here? So if we break it up into chunks of 2, right? So the max here, because B is not greater than A, this profit is 0. Here, this profit is B minus A, so it would be 3. So we would say that the profit of this whole system now then is 3. The maximum that we can make in this is 3. So I think that would work with any combination of 3 numbers. So let's say I have 199. I'm just going to make up some examples. Let's say I have like 199 and let's say 502. So the maximum with these two is 8. The maximum of these two is 0. So the maximum of this whole system is 8. Now this is a particularly interesting example because if you buy here and sell here, it's 8. And if you buy here and sell here, it's 8. So there's actually another thing to consider that I wasn't thinking about, is that you could buy on the first day and sell on the last day. So for instance, if this answer was 1, okay, so the old way I was doing it was, if you look at the profit here, it's 1 and the profit here is 3, so you say the whole system is 3. But that's not actually true. The whole system is really 4, because you can buy here and sell here. So I think an important thing to note is that there is a different problem like this that's called best time to buy and sell stock. I think it's one of these. Yeah, this one. So I'm going to try not to look at the answer here. Okay. So this one, I don't know if this is cheating or not, but I want to look at this problem and maybe solve this first and see if it can, because a lot of questions are meant to be solved sequentially. So I wonder if looking at this one can help me approach the next one, and maybe each subproblem would be the answer to this. Yeah. And I believe this can be done in linear time. So yeah, so but the issue with this is you only get one you can only buy one coin. Yeah. So with this one, I remember this one was deceptively difficult for me. I don't know why. But I would probably start with a minimum. So let's look at this and then we'll get back to that. So I would, if we have 10, 1, 5, 6, 7, 1. So our minimum starts out at 10. And then I would calculate the max profit we can get with this minimum. So our min starts here. I'll just say we have like I and J. So our minimum starts here. The max profit we can get here is a -9, but we found a new minimum. So this becomes 1. The max profit we can get now, so the profit we can get is 4. And then it becomes 5, and we still haven't found a new minimum. And then it's 6. and then here is 0. So I would probably do it this way, and then let me just see if it works for the other one. So these would all be 0. Yeah, so that would just never work because we would never find a new minimum. Or we would, but we would never make a profit. So let me see if that would work for this one. So prices of 0, just say like max profit is 0. And then we'll say I equals 0. I don't think we need the index value, so we could say for price and prices, if price. Okay, so first we want to probably calculate the profit. So if or I guess we could say max profit equals the max of itself, and price minus minimum. So whatever we're at minus the minimum. And then we'll say if price is less than minimum, well, I guess we could just say minimum equals the min of itself and price. Okay, let's see if this would work, and then we would return max profit like that. All right, so that. Okay, so this solution is O of n. So is it possible that we'd be able to do it for every subproblem? So let me, I'll keep that there. So now we have an answer to being able to solve a subproblem. So if we have 1, 3, 4, 0, 4. So we could figure out this, you know, we could figure out every subproblem. The problem with that is we can buy multiple coins. So we could do like that, and then this. Well, not because of the cooldown, but like something like that, right? So I think that's where dynamic programming comes into play, is we can remember the subproblems and then just somehow pick the best combination. Yeah, so the cooldown is a bit tricky, but without the cooldown, let's assume there was no cooldown for now. How would we solve it? Well, I would say if the max profit you can get from here is positive or 0, I guess, then the max profit of the whole system is the max profit here plus so the max profit here plus the max profit of all of this. Okay, so that's like the whole system. And then to figure out the max profit of the second orange part, you could say, well, that's the max profit of here plus the max profit of all of this. And then you can just kind of keep going with that logic. Like, it's very recursive in this way. And then we eventually would get our base case, which is the single profit. Although in our case, the base case may look different. So if there was no cooldown, I don't know if this would. So that's like a general sort of recursive approach, but I don't know if it would work in this case. So the solution is all about finding the minimums. Yeah, so I'm sort of torn in two directions here. If we should continue with the idea I have there, or if I should try to think of something else. But because what is the base case? Like, it's not really when you have 1 in this example, because the base case of anything would be 0. So you would just say 0 plus the rest of this, and that's equal to 0 plus the rest of this. So if you did it that way, you would get 0. And if we have 2, I don't really think that, I don't think that makes it any better. Okay, what if we started by doing the solution on the whole thing? Maybe. So we could say, okay, so we could do the solution, or we could just record all the max profits. Okay. So what if we recorded, like, okay, if we stopped here, we could get a profit of 2. If we stopped here, we could get a profit of 3. This would be 0. This would also be 3. So now it's a matter of what's higher, 2 plus this, or 3. Okay. So what's higher, 2 plus what we can get here, or is it 3 plus what we can get here? So we know this would be 0. So this tells us that it's 3. The whole system is 3. If we buy here and sell here, then our whole system is 3 because it's equal to 3 plus whatever we can get from here, and this is 0. So that's 3. In this case, it's 2 plus whatever we can get here. So we could just do another O of n calculation and say, okay, so we'd buy here, and then we could sell here, and then this would be 3. So I think these two are only the same because this happens to be a 0. In the case that this was a 1, this answer would now be changed to a 2. So is there any way we would just know which one is better? Maybe we could start from the right. Okay, so let's imagine that this is our system. So here, the maximum value we can get here is 0, of course. Here, the maximum value we can get here is 3. So I would say 3. The maximum value we can get here is 3. I'm trying to identify the recursive step. So here the maximum value we could get is 1. No, it's 3. And the reason I'm saying that is because this is just bigger. So what we could do is, okay, so with this example, when we're here looking at this one, there's really only 2 options. It's the max of what came before, or we compare 4 and 4. Like, let's say this was -10, or not -10, let's say it was 0. Then that would be bigger. So we compare this versus that. So that's a constant operation. But now when you add this layer, so I guess this is also 3. Is it as simple as comparing these two versus this one? I feel like it's not, because now you can buy and sell here plus this one. So now you'd have to check this one plus this one. In this case, though, it's still 3. Let's look at maybe a more complicated part. So now the final, so this you could just take 3, but can we get something bigger? Well, here we know you could get 2. So this would be 2. And then this is 3. So my question is, like, do we have to look anywhere else? Like, what could we look here and say, okay, this is 3, but here is 0. So I guess it's like your calculations then would almost be, so you can do this. So it'd be 2 plus whatever you obtained over here. Or it would be 4 minus 1. So 3 plus, if you skip 1, which is 0, then you take the max of that, which is 5. Okay. Yeah, but that's because I modified the answer. Okay, so I think I'm kind of getting somewhere, to be honest. I don't know if it seems that way to you guys, but we're at 26 minutes. Okay, so here the profit is 0. Here the profit is 4. Here the profit is either, so it's the max of 4 minus 0, this one, or just 4. So that obviously is 4. Or sorry, it should be negative 4 or 4. And that's 4. Because it would be really 0 minus 4. So I'm going to write that. So it's either 0 minus 4 or it's just this 4. Okay, so the max of that is 4. This one is the max of, so we could buy and sell here, which would be 4 minus 3, and then we would do plus the max over here, right? So our sell point, so like we skip 1 after our sell point, which would be 0. Or it's, is that our only other option is just 4? Do we have any other options? Could I buy here and sell here hypothetically? Like if this was, so if we had 1, 3, 4, let's say 8 and 4. So here would be 0. This would be 0. This would be 4. 4 minus 8. But this then could be 5. Because you could also do this. You also could do 1 plus 0, like 4 minus 3 plus 0. So we also have to consider this. I think this example is too short for me to get anything meaningful from it. So I'm just going to do a longer example. Okay, and then I'll say 10. All right, so here it's 0 because it's only 1. Here, our only option is we could do nothing or we could buy sell. So if we do nothing, we just take that one. So there's always the option where you just do nothing. So this would be the max of doing nothing and 10 minus 9, which is 1. So this then would be 1. Now for 5, we have a couple options. So A, we could do nothing. So if we do nothing, that's 1. We could buy sell, and then this would get skipped. So that would be 9 minus 5. Or we could buy here and then sell here, and that would be 10 minus 5. So the max of all those is 5. So 5 is the answer here. Okay, now what are our options here? So we could do nothing and take 5. That's just taking this. We could buy sell, which would be 5 minus 9. We could do 9 minus 9. Or we could do 10 minus 9. So I'm trying to just locate the redundant work. So this would be 5 again. Okay, so maybe now that we're here, we won't have to do some calculation maybe. Or do we? I was thinking like maybe since we're here, I guess because it's a, we could always, if this is a lower number, it doesn't really matter the maximum we could have made up until that point, does it? Because this could be 6 plus 1. So we could do 6 plus 1, or we could do 2 plus 0. So we can sell at any one of these points, or we could just do 7. So that would be n squared, I think. Maybe that's the solution. So you could sell at all of these points. So, and if we were to sell here, we would also add this number. Could that be it? Okay, so sell here, so that would be 6, this would be 2, this would be 6, this would be 7. Actually, wait, so this would be 6 plus 1, 7. And what that is you would get 6 here, and then you could buy, sell here, and get one more. So you get 7. You could sell here and get 2 from this exchange, and then add 0. So that's 2. Okay, so I think at every point, it's, so this would be n squared, which I think is great for this type of problem. So this would be 7. Okay, so now here, we'd be able to look at all of these. So this would be -2 plus 5, which is 3. This would be 4 plus 5. Wait, we sell here, so then we would get this one. So it would be this would give us 4 plus 1. So this would give us 5. Then we could look here, that would give us 0 plus 0. Or we could do 4, or we could just do 4. We could also just sell here, and just that would give us 5. So what really is the best option? Okay, so I'm going to delete everything so far. Okay. So to calculate this, we would have to do one for everything. Okay, so we would start here. So selling here would give us 5 minus 3 plus whatever it is 2 spaces away. And then we can also do nothing. Is that true? Is that true that we could just do nothing? Because if we do nothing, then we could say it's 7. And then this should be, yeah, because like let's say later on if we sold, like let's say there's infinity numbers to the left and we sold here. If this was, let's say we calculated it to be a number less than 7, for instance, 3, we wouldn't do +3. We should actually just do 7. So this would be 7, because we could just wait and not buy here, but actually buy here. So we could also just pass. Okay. So it would be, so let's see, is there anything bigger than 7? So here it would be, now there's another question. Would we even sell here if it's, would we buy, sell to just lose money? Probably not. We'd rather just wait. So I think we'd only consider buying and selling if the sell point is bigger than the buy point. So this would give us 4 plus 1, which is 5. This would give us 0. So in the case of 0, I think it's probably better to just do nothing. I don't know. So it'd be 0 plus, it would be 0, it would be 5 minus 5 plus 0. This would be 4, and this would be 5. So the best case in this whole substring is to do nothing on this step and just buy here, and then you can, we know that you can get 7 because of our dynamic programming. So this would be 7. So I'm going to delete that. This would be 7. Okay, 36 minutes. So now this one, so this is not lower, sorry, this is lower, this is lower, this is not. So this would be 2 from 9 minus 7 plus 1 is 3. This is lower, this would be just 2, and this would be just 3, so 7 is the highest. And then this, everything is lower than 2, so we would just say 7. Okay. And we don't have to return the indices, right? Okay. So what this is telling me is you don't do anything for these 3, which makes sense looking at it. Well, I wait. No, it doesn't make sense. I think I made an error on the last one. I think what I was doing before was correct, though. You don't want to skip things that are smaller than you. You want to, or yeah, this 2 has opportunity. So the 5 should skip the 3. It should skip the 5, and that's it. The 7 should skip the 5, skip the 3. Yeah, and then we determine the biggest one here. 2. All right, so this is where I made my error. Previously, I said 2 should skip everything. That is not true. 2 should not skip everything. It should skip anything that's lower than it, and nothing is lower than it, so it should skip nothing. So here would give us 5 plus 7. So that's 12. This would give us 3 plus 5, which is 8. This would give us 1 plus 5, which is 6. This would give us 7 plus 1, which is 8. This would give us 3 plus 0. This would give us 7. This would give us 8. So the biggest there is 12. So I would say that the final answer here is 12. And how did I get that? Well, I believe how I'd get that is I would buy sell here to get a profit of 5. Then I would buy here, sell here to get a profit of 6. And then I would buy here, sell here to get a profit of 1. And that would give us 12. And we can tell based on the numbers. So this is 9 minus 6 plus 1. Okay, so this would run in n squared time, and I'm pretty sure it works. So before I start coding it, so we're looking at 40 minutes. You know, I would like to get it faster, but I'm happy I have something now. So I'm just going to fact check it on the solution, or on the example. So this would be 0. Now this, we check by selling it everything that's greater. And let's just imagine there's like some zeros over here. In our DP array. So our DP array is up here, and we'll just have 2 zeros at the end. So this is, if we sell here, it's 4 minus 0 plus 0, 4. Or it's just if we do nothing, 0. So in this case, it would be 4. Okay, now here, this is, we skip this one because it's less than, and I think we just skip this one because it's the same. So then it's 0, 0, or doing nothing, which is 4. This, okay, now this one, we could buy sell here, which would give us 1 plus 0. So it's either 1 plus 0. We skip this one, or over here it's 1 plus 0, so we'll take 4 again. Okay, now for the 1, so we could buy sell here, and that would give us 2 plus 2 spaces ahead, which is 4. We could buy sell into this square, which would give us 3 plus 0. We'd skip that, and this would give us 3 plus 0. So the maximum here is 6, or we could do nothing for 4, and then we'd get 6. All right, so that looks good. Okay. My throat is like super dry from talking. I don't have any water. All right, looks good. So I'm going to have a dynamic programming array, which is going to be equal to 0 times length of prices plus 2. So I'm just going to add 2 more, just because let's say if we sell at the last point, I just want to go out of here and access this too. And that shouldn't mess up our indexing. It might. There's workarounds to that. If it's out of bounds, we can just do 2. Okay. So now what I want to do is say I equals 0 while I is greater than length of prices. So this would be a normal while loop, but I actually want to loop backwards. And can I just do a for loop here? I think maybe I just do a for loop. And then inside will be the while loop. Let's try that. So for price in prices, actually for I in range length of prices minus 1 minus 1 minus 1. So that will loop through it backwards, starting here. And then what we want to do, so let's say we're in the middle, the general case, we want to loop, so we'll set j equal to I guess, so we'll have j be here, and it'll start at I plus 1, and then we'll say while j is less than the length of prices, so j will be here, j will be here, j will be here, it'll exit. So we will do no calculations here. We will print, and of course j plus equals 1, and here I plus equals 1. Or no, we don't need that because it's a for loop. So in here, I'm just going to print ij for now. And let me just make sure that's working as I want it. So parentheses. All right, so in this case, we're starting at I equals 3, 0, 1, 2. Let me undo all the purple marks. Okay, so 0, 1, 2, 3, 4. So we're starting at I equals 3, huh? 0, 1, 2, 3. Don't we want I to be 4? Why is it not? It's starting at length minus 1. Oh, is it because j starts out of bounds? So it's actually here, but then j gets set to I plus 1. maybe I could just set it to be equal to I, and that won't mess anything up. Yeah, so 4, 4, 3, 3, 3, 4, 2, 2, 2, 3, 2, 4, 1, 1, 1, 2, 3, 4, 0, 0. Okay. Great. So this is n squared. So if I can do the algorithm here, it would be n squared, which I think is good. For a 2D dynamic programming problem, I think n squared's like the what you're going for. Okay, so now what do we want to do? So I was basically comparing the profit at every point. So here, max profit would probably be reset to 0. And then when we're done with the while loop, we would set dp of I equal to max profit. Okay, so that's that. And then at the end, we're going to return dp of 0, like that. So how do we actually calculate max profit for a given point? Well, so it'll start by comparing itself, which is not what I want necessarily, so let's just ignore that. So it will compare, so it's basically asking the question, what if I sold here? So we would say profit equals, yeah, so it's equal to, well, first of all, if prices of j is less than or equal to prices of I, so if this is less than or equal to this one, we just want to skip it, and that'll solve when it bounces on itself. Okay, otherwise, so if it's greater than, then let's calculate what the profit could be. So the profit would be equal to prices of j minus prices of I plus dp. So let's say if we sold here, we want to get dp of j plus 2, j plus 2. So we want to get dp of j plus 2. And then we want to set max profit to be equal to max of itself and profit. All right, let's try something like this here. Return is outside of the function. Okay, we may have an infinite loop. Yeah, we definitely do have an infinite loop because it wouldn't TLE on this here. So while j is less than the length of prices, it continues. Yeah, so we need to say j plus equals 1 here. All right, so it worked for the 2 test cases. Let's see if it fails here. So 2, 1, 4. Let's see if that's a... Oh, we also need to compare it to dp of I plus 1. I don't know if this is the reason the test case, but like, so that's equivalent to doing nothing. I don't know if that'll fix the exam. I should have saved it. All right, let's see what this one is. 4, 1, 2. My output is 0, but it should be 1. That makes sense. So if we have 4, 1, 2, starts 0. Right, and then this one should be, we would compare I and j, and then we'll say, okay, well, it would be 2 minus 1 plus 0 or 0. So it should say 1. And then this one, okay, let me just troubleshoot some stuff here. So let me print dp at the end and see if it's what I'm expecting or not. So okay, that's what I'm expecting. So how is so I'm thinking it should, so when it gets to this point, it'll say I can't sell, so it'll say continue, continue, continue. Oh, I see. So in this case, we want to set DP. Are we never setting DP? Yeah, we're also never setting DP as well. So if you can't sell into anything, then what does that mean? That means that you should just take the previous one. So dp of I equals dp of I plus 1. And then, of course, oh no, we are setting it here actually. I think it might have just been this continue statement because we weren't setting the dp if you continue. Okay, still didn't work. We also should set max profit then to okay, now this one, yeah. So maybe yeah, that's not right. Okay, so let's think, what happens when I'm skipping? What do I really want? What do I really mean when I'm skipping? So then we're saying the profit would be 0, right? So what if we just say profit equals 0? And otherwise, profit equals this. So, okay, the profit here is, it's just 0. Is that true? Well, I guess you wouldn't want to sell there. All right, let me see if that works. All right, that seemed to work. All right, awesome. Okay, so ended up solving it 52 minutes in. I wasn't really sure if I was going to be able to get it midway through there. Yeah, so, yeah. Is this necessary? It may not be necessary, actually, now that I'm looking at it. Because this would just be negative. Yeah, all right. So logically speaking, it makes sense to skip it, but it's not necessary because this will evaluate to a negative number, which will not get selected here anyway. So yeah, great. Okay, so quick recap. I'm really glad that I stuck to the dynamic programming fundamentals of looking at the subproblems and figuring out how to use, I think it's called the recurrence relation, or how to use, in my subproblem, how can I use the answer of a previous subproblem to get me the answer? Yeah, and I'm also glad that I figured out that it would just be n squared. I hope there's no linear solution. Let me see if there's a linear one. Oh, they're linear. Okay. Well, that's unfortunate. But I am still happy that I got a somewhat good one. Yeah. I could think about the linear solution, but I think for the purpose of today's video, I'll just keep it quadratic, and then I'll probably look at the solution another time. So I'm going to see if I can submit it on LeetCode. It might actually get buy and sell crypto with Cooldown. Is that what it's called? Buy and sell crypto with Cooldown. Okay. So it might actually TLE on LeetCode because usually LeetCode's a little bit more strict with their timing. Yeah, okay, so it got accepted, but it's clearly there's a linear solution. So that must mean then that you don't actually have to check every sell point, which doesn't intuitively makes sense to me, unless you just kept track of maybe the maximum or something. Yeah, so either way, I didn't get the best solution, but I'm happy I got at least an n squared solution. And I'll definitely make sure to look at the solution for this one. And yeah, thank you guys for watching. Pretty happy I got that, to be honest. And yeah, I'll see you guys tomorrow for day 61.